Yes. China, good morning. Morning. Today, listen. The various mechanism related to the conductivity of the solutions. Various ways where conductance can be expressed. Regarding that, I am discussing. This is what we say it as conductivity cell. Conductivity cell. A vessel which is filled with an electrolyte. Electrolyte can be either an acid solution or base solution or salt solution. Any good electrolyte which we take in the cell is referred as conductivity cell. This conductivity cell is filled with either acid solution or base solution or salt solution, in which two electrodes are suspended. That electrode bottoms are fitted with one what you call platinum black strip, a platinum black strip having certain cross sectional area, and these are the electrodes separated. This is cross sectional area A, cross sectional area A, and this is what filled with electrolyte. This is filled with electrolyte, and this is the distance is said to be L distance. These electrodes are suspended parallel to each other in the conductivity cell. Right. What we learn from this, I'll come to know. I'll get to know. So now you have seen in the electricity, in the electrostatics, you have seen in the electronic conductors, metallic conductors, in the conductors, there is a flow of conductance. There is a flow of conductance, means passage of electricity, passing of current through a conductor. There is a thing which is getting operated is resistance, capital R. Resistance stands stopping potential, you can speak. Stopping potential of current. Stopping potential of current. That is what we say it as resistance. Resistance is the term which is operating opposite to the flow of current in the conductors. That is what you learned under the heading of Ohm's law. Ohm's law. How we see Ohm's law in the metallic conductors or in the electronic conductors, how we see that there is a satisfying result is there, that there is a R to the flow of current in the conductors. Resistance R to the flow of current in the metallic conductors or in the electronic conductors is observed in the electricity chapter or in the electrostatic chapter in the second year in physics. So Ohm's law can also be extended to any electrolytic solution. Sorry, any electrolytic solution like acid solution or in the base solution or in the salt solution. Whatever the electrolyte which we see, which we take in the conductivity cell, there is a satisfying of Ohm's law. Satisfying of Ohm's law. How we see Ohm's law is getting satisfied in the electronic conductors, same Ohm's law can also satisfying in the electrolytic solutions. Electrolytic solutions also satisfies the Ohm's law. Electrolytic solutions also satisfies the Ohm's law. electrolytic solutions, acid solutions, base solutions, salt solutions, in water solutions also satisfies the Ohm's law. Sorry. In the conductivity cell, we have taken its electrolyte. Now, resistance R. Resistance R. Conductivity cell. Conductivity cell. Electrolyte we have taken. Electrolyte we have taken. Suspended two electrodes. Suspended two electrodes. Suspended two electrodes enclosed in the tube, having a strip here, having cross-sectional area A, and these two parallel electrodes are separated by a distance of L centimeters or L meters. Two electrodes are separated by means of a distance is L centimeters or L meters. Strip is having some cross-sectional area A. Cross-sectional area A, small a. Now, electrolytic solutions also offers resistance. Electrolytic solutions also offers resistance R to the flow of current. Exact situation we have seen in the electronic conductors. R is the resistance to the flow of current offered in the electronic conductors. Resistance R to the flow of current in the electronic conductors is observed. Similarly, Ohm's law is also satisfying. Ohm's law is also satisfying, or electrolytic solutions also satisfies the Ohm's law. Electrolytic solutions also satisfies the Ohm's law. Resistance offered by the electrolytic solutions. Resistance offered by the electrolytic solutions to the passing of electricity. Right? Resistance R to the flow of current. Resistance R, capital R. Resistance capital R. Resistance capital R to the flow of current. Current is getting offered by electrolytic solutions is directly proportional to. Means resistance is directly proportional to resistance offered by the electrolytic solutions. Resistance offered by the electrolytic solutions. Resistance existed, or resistance is getting operated. Resistance R is getting operated. Resistance is the phenomenon which is getting operated, is the mechanism which is getting operated. Resistance R is getting operated. So resistance R to the flow of current by the electrolytic solution means a stopping potential of current. Stopping potential of current. Some obstruction of flow of current. Some hindrance in the flow of current in the electrolytic solutions. So in the electrolytic solutions, the resistance R to the flow of, resistance R to the flow of, ఇదే బాగా వినండి, resistance R to the flow of, resistance R to the flow of current offered by electrolytic solutions is directly proportional to distance between the two parallel electrodes, and inversely proportional to cross-sectional area of the electrodes. So this is the, here in the electrolytic solutions there is a flow of current, resistance R which is operating in opposite direction to the flow of current. Resistance which is operating to the flow of opposite resistance R is operating R is operating opposite to the direction of flow of current. Opposite to the direction of flow of current means stopping potential of electricity. Stopping potential of electricity. Stopping potential of conductance. Stopping potential of conductance. Stopping potential of that electrolyte. Resistance R to the flow of current offered by the electrolytic solutions. R is directly proportional to distance between the two electrodes, which is L, and inversely proportional to cross-sectional area of the electrodes. Distance is this distance. This distance. This is the distance. These are the electrode distances. L can be like this. L can be like this. This is L. Resistance R to the flow of current offered by the electrolytic solution. Stopping potential R to the flow of current offered by the electrolytic solutions is directly proportional to distance between the two parallel electrodes and inversely proportional to cross-sectional area of the electrodes. So R is directly proportional to this. So R is equals to some constant S into L by A. Here R is resistance. R is resistance. L is distance between two parallel electrodes. A is cross-section area. Cross-section area of electrodes. And cross-sectional area of electrodes. Okay. S is specific resistance. S is specific resistance or resistivity. ఇక్కడ ఏం లేదు, చిన్న లాజిక్ ఉన్నది. Ohm's law we have seen in the physics. Ohm's law we have seen, observed in the physics. There is a resistance. Resistance is stopping potential of current. If current is flowing in one direction, from A to B, assume resistance is getting operated in opposite direction. There is a stopping of current passing partly getting stopped. Say 100 volts is passing from A to B. That is 100 volts is getting passed from A to B, no? That is after stopping potential, 100 volts is passing. Certain extent of getting obstructed, passing from A to B. Certain extent of current is getting stopped from A to B. That certain extent you are speaking in terms of resistance. Obstruction, obstacle, prevention, breaking of current. Breaking of current stands, passing of current is getting broken, partial. R is direct now. Resistance R to the flow of current offered by the electrolytic solution. Electrolytic solution is stopping the flow of current. Electrolytic solution is, correctly speaking, electrolytic solution is the solution which will pass current, which is due to the presence of positive and negative ions located in the acid solutions or in the base solutions or in the salt solutions. So those are the ions which are responsible for the flow of current. Those are the ions which are responsible for the flow of current. So those ions are responsible for the flow of current from one direction to other direction. You can assume there is some stopping, obstruction media is getting operated due to the same particles. Due to the same particles. Maybe zigzag movement of ions in the solution. Maybe random movement of what you call ions in the solution. Random movement in the solution. Random movement of ions in the solution. Random movement may be responsible. Random movement may be responsible where R is getting operated in the solution. If the electrons or ions are straight away passing, then there can be 100% efficiency will be there in the current production. But some electrons might be operating or might be having movement opposite to the what you call flow of current. If electrons are passing from A to B, current is crossing from B to A, like that. So this zigzag random movement of electrons, random movement of ions might be responsible operating of this R. So that R is resistance offered by electrolytic solution. Resistance R representing that property is with R. That opposite property which is there, some obstruction property is there, stopping property is there, that stopping property R, speaking in terms of resistance. Resistance R to the flow of current offered by the electrolytic solution is directly proportional to distance between the two parallel electrodes. R rises, or increases agar distance between the two parallel electrodes is increased. R is the resistance is rising agar distance between the two parallel electrodes is increasing. Zyada distance, zyada resistance. Smaller distance, smaller resistance. Resistance is directly proportional to distance between the two parallel electrodes and inversely proportional to cross-sectional area of the electrode. R is directly proportional to L by A. That L by A can be called as cell constant. Cell constant. Look here, cell constant. So now R is this, and we have what you call removed this directly proportional. Yes, we have kept. Yes, we have kept. So this is the formula. Now this reciprocal of R is the conductance. Reciprocal of R is conductance. I have taken denominator. I have taken denominator to the resistance R. I have taken denominator to the resistance R. This 1 by R is equal to 1 by S into 1 by L by A. 1 by R is equal to 1 by S into 1 by LA. Entire thing we have shifted to denominator. 1 by R is said to be conductance C. 1 by S we say K is specific conductance. S is specific resistance. S is specific resistance. S is specific resistance. Specific resistance. 1 by S is specific conductance. 1 by S is specific conductance. S is specific resistance. 1 by S is specific conductance indicated with the letter K, specific conductance, into 1 by L by A. So K is equal to C into L by A, where K is equal to specific conductance. Right? C is equal to conductance. First, ఇంకా ఉన్నది, still we have. First of all, shall we copy down this one? I have to rub it. Write down. Ohm's law. Write down the point. Ohm's law satisfies. Ohm's law satisfies the conductance in electronic conductors. Ohm's law satisfies in electronic conductors or in metallic conductors. Continuation. Similarly, electrolytic solutions also satisfies the Ohm's law. Next point. In electrolytic solutions, you're writing the point. In electrolytic solutions, resistance capital R in electrolytic solutions, resistance capital R to the flow of current offered by the electrolyte in the solution taken in the conductivity cell. By the solution electrolyte in the solution, current offered by the electrolyte in the solution in the conductivity cell is directly proportional to distance between the two parallel electrodes suspended in the electrolyte suspended in the electrolyte is directly proportional to, you wrote, Nihant, you read once, Nihant, read once what you wrote, read once, call me. Nihant, call me. Yes, Nihant. Yes, any one of you call? Abhiram, you read out that sentence. Resistance R to the flow of current offered by the electrolyte in the solution.
Electrolyte in the solution taken in the conductivity cell
Ah,
is directly proportional to the
Ah.
distance between the two parallel electrodes.
right, suspended in the
In the electrolyte is directly proportional to అక్కడ వరకు ఆపేసి
మళ్ళీ ఒకసారి చదువునా, మళ్ళీ రెండు సార్లు వచ్చినట్టుంది డైరెక్ట్లీ.
In electrolytic solutions, resistance R to the flow of current
Ah.
offered by the electrolyte
Ah.
in the solution taken in the conductivity cell
Ah.
is directly proportional to the distance between the two parallel electrodes
Ah.
suspended in the electrolyte.
And inversely proportional to continuation, and inversely proportional to cross section area cross section area electrodes, cross section area electrodes, cross section area electrodes, cross section area electrodes. Mathematically as follows. Write this, giving tick mark first. Any second, సైడ్ లో ఇది పెట్టుకోండి. ఫస్ట్ ఇది కాపీ చేసుకోండి. ఫస్ట్ కాపీ డౌన్ దిస్, మేక్ ఇట్ దిస్ ఇస్ సెకండ్, దిస్ ఇస్ థర్డ్. ఫస్ట్ దట్ conductivity cell over Tommy. చిన్న కాపీడా ఒక రెస్పాన్స్ ఇవ్వరా మెసేజ్ పెట్టరా ఒకరు మెసేజ్ పెట్టండి ఒకరు మెసేజ్ పెట్టండి Understood and completed, sir. Abhiram. Right. Copied, sir. Right. ఇంతేనన్న ఏందంటే ఇక్కడ the electrolytic solution is stopping the current. We say in terms of resistance. Resistance are to the flow of current offered by the electrolytic solution. Mathematically is experimentally is directly proportional to distance between the two parallel electrodes and inversely proportional to cross section area of the electrodes. So R is directly proportional, like this we have taken. We have taken the reciprocal of this. Reciprocal of this is this. Reciprocal of resistance is conductance. Reciprocal of resistance is ikkada R resistance, L distance, A cross section, S specific resistance or resistivity. So inverse we have taken. The inverse of resistance is conductance, even in the electrostatics also. Reciprocal of resistance is conductance. 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 C. C is equal to reciprocal of specific resistance is specific conductance. Reciprocal of specific resistance. Reciprocal of specific resistance is a specific conductance K into 1 by L by A. Now K is equal to this thing. So this is what we say it as K is equal to specific conductance. ఏంది సార్ ఈ స్పెసిఫిక్ కండక్టెన్స్ అంటే స్పెసిఫిక్ కండక్టెన్స్ ఆఫ్ ఎలక్ట్రోలైట్ మే బి డిఫైన్డ్ యాజ్, మంచిగా వినండి, స్పెసిఫిక్ కండక్టెన్స్ ఆఫ్ ఎలక్ట్రోలైట్ మే బి డిఫైన్డ్ యాజ్ స్పెసిఫిక్ కండక్టెన్స్ ఆఫ్ ఎలక్ట్రోలైట్. The specific conductance is the term corresponds to electrolyte. Specific conductance of electrolyte may be defined as the conductance or conductivity of solution. Conductivity of the solution which is enclosed between the two parallel electrodes separated by a certain distance, 1 centimeter or 1 meter, is called as specific conductance. Specific conductance of electrolyte may be defined as the conductance of electrolytic solution. Conductance of electrolytic solution which is filled between the two parallel electrodes in the conductivity cell is called as specific conductance. It's called specific conductance. So specific conductance of electrolyte is defined as the conductance of solution. The conductance of solution which is getting produced because of electrolyte and which is enclosed between the two parallel electrodes having the distance 1 centimeter or 1 meter and provided one what you call square centimeter of cross sectional area is called as specific conductance. Specific conductance means conductivity, passing the flexity. Specific conductance may be defined as the conductance of solution. The conductance of solution, current generating in the solution. That solution is enclosed or that solution is available between the two parallel electrodes that are separated by a unit distance or that are separated by 1 centimeter distance, separated by 1 meter distance, and that electrodes are fitted with some what you call cross sectional area, means some strip which is having cross section, and that cross section is 1 square centimeters. So now current which is getting generated by means of electrolyte located between the two parallel electrodes which are separated by 1 centimeter unit distance is called as specific conductance, indicated with the letter K. నిర్దిష్టమైనటువంటి కరెంట్ ప్రొడ్యూస్ అవుతుంది. ఎక్కడి నుంచి? ఎలక్ట్రోలైట్ నుంచి. ఎక్కడుంది ఎలక్ట్రోలైట్? రెండు ప్యారలల్ ఎలక్ట్రోడ్స్ మధ్యలో ఉన్నది. రెండు ప్యారలల్ ఎలక్ట్రోడ్స్ మధ్యలో ఉన్నది. ఆ ప్యారలల్ ఎలక్ట్రోడ్స్ 1 సెంటీమీటర్ డిస్టెన్స్ లో లొకేట్ అయి ఉన్నాయి. ఆ ఎలక్ట్రోడ్స్ కి కింది భాగాన ఒక చిన్న బిట్ లాంటిది ప్లాటినం స్ట్రిప్ కెప్ట్ ఇట్ కోటెడ్ విత్ ప్లాటినం బ్లాక్. ఆ ప్లాటినం స్ట్రిప్ ఈస్ having the area is 1 square centimeters. So this current which is getting produced, we call it as specific conductance. మరి ఆ సొల్యూషన్ ఏ కాన్సన్ట్రేషన్ ఉన్నా సరే అని అడగొచ్చు కదా మీరు, దానికి సపరేట్గా ఉంటుంది. ఆర్ యూ కెన్ స్పీక్ స్పెసిఫిక్ కండక్టెన్స్ మే బి లైక్ దిస్. Specific conductance may be like this. Specific conductance may be defined as the specific conductance of electrolyte may be defined as the conductivity which is getting produced. The conductivity which is getting produced by filling 1 cc of solution between the two parallel electrodes separated by 1 centimeter distance is called as specific conductance. 1 cc of solution is there, imagine. 1 cc of solution is there, imagine, between the two parallel electrodes in the conductivity cell. From that there is a production of current. That current is called as specific conductance. Specific conductance. So specific conductance may be defined as in both ways. Specific conductance of solution may be defined as the conductance of solution enclosed between the two parallel electrodes separated by a distance of 1 centimeter. Separated by a distance of 1 centimeter. Or otherwise, specific conductance K may be defined as the current generated from the electrolyte when it is filled in the conductivity cell for about 1 cc solution between the two parallel electrodes. In the conductivity cell between the parallel electrodes, we have filled is 1 cc solution. Mass a current is getting produced. That generated current is called as specific conductance. Conductance and ardhamendana flow of current. A flow of current by means of 1 cc of solution. Flow of current by means of 1 cc of solution. 1 cc of solution which is filled between the two parallel electrodes in the conductivity cell is called as specific conductance. Is this point is clear or not? Let me know it. ఇప్పుడు నాకు మెసేజ్ రాలి. ఇప్పుడు మెసేజ్ పెట్టాడు. Whether you understood or not. What is specific conductance? What is specific conductance? What is specific conductance? Please put the message. Clear, sir? Understood perfectly, sir. Right, super. Understood, sir. Right. అంతేనా? అది స్పెసిఫిక్ కండక్ట్. ఇప్పుడు దీని యూనిట్స్ లాక్కొద్దాం. ఒక్క యూనిట్ చెప్పేసి ఆపేస్తాను. దీని యూనిట్స్ లాక్కొద్దాం. ఈ రెసిస్టెన్స్ ఈస్ టోల్డ్ ఇన్ టర్మ్స్ ఆఫ్ ఓమ్స్. Resistance is told in terms of unit of resistance is R. Unit of resistance is ohms. R is equal to R అనేది ohms అనాలి. R is measured in terms of ohms. R is measured in terms of ohms. Sorry. Resistance is R ohms. You said C is equal to 1 by R. This is 1 by ohms. So C is equal to ohm inverse. R MHO. ఇది ఓల్డ్ రిప్రజెంటేషన్ అన్నది. ఇది ఓల్డ్ రిప్రజెంటేషన్ MHO. ఇప్పుడు K is equal to you said is C into L by A. C you said is ohm inverse. L is distance between the two parallel electrodes, centimeters. Cross sectional area centimeter square. So now ohm inverse and centimeter inverse, or ohm inverse meter inverse. This is representation. This is the unit of case, unit of specific conductance. Unit can be asked. Once it is asked is this: unit of electrochemical equivalent is dash. Unit of electrochemical equivalent is dash. Unit of electrochemical equivalent is dash. Ask. Possibility for asking unit of specific conductance, or unit of conductance, or unit of resistance. Resistance is in ohms, conductance is ohm inverse, specific conductance is ohm inverse, centimeter inverse. That you copy down. That you can copy. That you can copy. Ohm inverse, centimeter inverse in CGS system. Ohm inverse, meter inverse is in SI system. This L by A is a cell constant. L by A can be regarded as cell constant. L is in centimeters, A is a centimeter square, is equal to 1 by centimeter, which is equal to centimeter inverse is unit of cell constant. That's all for today. Unit of cell constant is dash. Unit of cell constant is dash. If cell constant is unity, conductance is equal to specific conductance. If cell constant is unity, conductance is equal to specific conductance. C is equal to K, or K is equal to C. ఇది యూనిటీ అనుకోండి, ఇది యూనిటీ, then K is equal to C. This is unity. L by A is unity. K is equal to C. Specific conductance is equal to conductance only. So unit of specific conductance, ohm inverse, centimeter inverse, or ohm inverse, meter inverse in SI system. Ohm inverse, centimeter inverse is in CGS system. ఇప్పుడు what is the last definition for specific conductance? Specific conductance of electrolyte may be defined as the conductance of solution whose capacity, conductance of solution whose capacity of passing current, the conductance of solution which is present, which means the conductance of solution, that is nothing but the electrolyte which is present between the two parallel electrodes separated by a distance of unit distance, having cross sectional area unit, is called as specific conductance. ఇంకా బ్రీఫ్గా చెప్పాలంటే conductance that is getting produced or conductance of a solution which is 1 cc, which is enclosed between the two parallel electrodes, is called as specific conductance. ఒక cc solution గనక ఒక cc సొల్యూషన్ గనక రెండు పారలల్ ఎలక్ట్రోడ్స్ మధ్యలో ఉండి కరెంట్ జనరేట్ చేస్తున్నటువంటి కరెంట్ని we say it as specific conductance. 1 cc solution will generate certain extent of current. That is what we call it as specific conductance. అందుకే word used is specific. This is shortly you can say omega inverse like this also. This symbol you might have seen in the physics. Omega inverse. Or like that ohm inverse, centimeter inverse. You say like this or you can speak like this. Better you go for this way. Go for this way. If this is clear, then we'll go for equivalent conductance and molar conductance with that and Kohlraasch law, with which we can say goodbye to this chapter. Right? Right now, 45 minutes only, sir told. So hence I am stopping it. Right? Thanks a lot. And I wish you happy Deepavali for everybody. Wish you happy Deepavali for all the boys and girls. Have a nice day. Have a great day. Thanks a lot. Bye, Nana. See you.